For our next question, let's practice using a tree diagram, and we're going to discuss how we label the branches and the ends of the tree diagram. Because these tree diagrams can really help us a lot when working with probabilities, not only in the problems we're going to do today, but in another type of problem that we will learn in the next section. Okay, so it says, in a survey of 1,000 eligible voters selected at random, it was found that 80 had a college degree. Additionally, it was found that 80% of those who had a college degree voted in the last presidential election, whereas 55% of the people who did not have a college degree voted in the last presidential election. Assume the poll is representative of all eligible voters. Okay, first we want to draw a tree diagram to illustrate this information. So let's go ahead and draw our first branches. The first bit of information that we had about these people picked at random were that they either had a college degree or they didn't. So I'm going to label my first branches D for degree and D complement for not having a degree. And it says that 80 out of the 1,000 random chosen did have a college degree. So if you divide that out, that divides out to 0.08. And that becomes our probability of picking a random person and them having a college degree. So that's this first probability. The probability of D then is 0.08. And the probability then of D complement is 1 minus 0.08, which is 0.92. So those are my first two branches and their probabilities. Now, off of each one of these branches is then discussed whether the person chosen voted or did not vote in the last presidential election. So I'm going to label each of these secondary branches vote or vote complement. Vote or vote complement. It says that 80% of those who had a college degree voted in the last presidential election. So let's stop there. That is this uppermost branch, the probability that someone voted, given that we already know that they have a degree, right? They had a degree, and now we found out that they voted. So that's 80% or 0.8, which means that the probability that someone did not vote, given that they had a degree, must be 0.2. The complement of that. And then we're told that 55% of people who did not have a college degree voted. So that gives us our next branch, the probability that they voted, given that they do not have a degree, was 0.55, which means that this last branch, the probability that they did not vote, given that they do not have a degree, is 0.45. And then what we can do, now that we've got all of our branches labeled, is we can go through and we can actually label, we can label the intersections off of the end. So the end will be the probability of this first uppermost branch, the probability of D intersect V. The probability that someone does not have a degree and voted is calculated by doing 0.08 times 0.8. And if you multiply that out, you should get 0.064. The probability of having a degree and not voting is 0.08 times 0.2, which is 0.016. The probability of not having a degree and voting is 0.92 times 0.55, which is 0.504. And lastly, the probability of not having a degree and not voting is 0.92 times 0.45, which is 0.414. So these are all of the possible pieces, everything that you get out of a tree diagram. You get the first branches, you get the second conditional probability branches, and then when you multiply through from the whole branch out, you get the intersections. Now we can answer pretty much any question that they could ask us about this situation. So let's see what we're asked now. Find the probability that an eligible voter selected at random had a college degree and voted in the last presidential election. So they're asking us for one of the intersections, and specifically they're asking us for the degree intersect vote. So we already did that. That was the first answer we got, which was 0.064. So I can just recopy that back down. Then they ask, what's the probability that the voter did not have a college degree and did not vote? So what's the probability of D complement and V complement? Okay, well that's this last one, the 0.414 that we already calculated. What's the probability that the person just voted in the last presidential election? So the probability of V, that they voted, regardless of the degree situation. So what we want to look for there is any branch that ends in voted. So we definitely want to look at this 0.064, and we also want to look at this 0.405. So if we add together the people who had a degree and voted and the people who didn't have a degree and voted, then now we've added up and found all of the people who voted. So that's what we can do when we want to find the probability of one of those right or more branches, is just do an addition. So 0.064 plus 0.504. Let's see what that is. So if we do 0.064 plus 0.504, that gives us 0.568. And then it asks us, are D and V independent events? And what does that tell us? Okay, so in order for events to be independent, recall the formula that we used there. That means that the probability of the two events intersection, so D intersect V, has to equal the probability of D multiplied by the probability of V. That's true if you have independent events. So let's check to see if this works. The probability of D intersect V is this 0.064. So this value that we found up in part B, so 0.064. Does that equal the probability of D times the probability of V? Let's go back and remind ourselves. The probability of D was 0.08. And we just found the probability of V being 0.568. So if we multiply together 0.08 times 0.568, we do not get 0.064. We get instead 0.04544. So because this does not work, this rule doesn't apply here, that means they are not independent. They are actually dependent. So what that tells us is that having a degree and voting are related to each other in some way. They affect one another. So knowing whether or not someone has a degree could change your opinion on the likelihood that they voted in the last presidential election, and possibly vice versa. If you know that someone voted, that might change your opinion about whether or not they have a college degree. So I'm not going to speculate as to why or delve into any of those ideas. But one thing we do know is that those two events are indeed dependent on each other.